Assalamualaikum, my name is Kamal and I'm with Talal.
So we're going to explain the Intel's architecture of latest processors for low power and thin laptops. The Kaby Lake architecture is used in latest processors for ultra low power and thin laptops. The most common processors used are Kaby Lake Y and Kaby Lake U. The Kaby Lake microarchitecture is Intel's successor of Skylake, an enhanced 14 nanometer process microarchitecture for mainstream desktops and mobile devices. Kaby Lake is the first optimization released as in part of Intel's POM model. The microarchitecture was developed by Intel's R&D center in Haifa, Israel. Cannon Lake was originally set to replace Skylake as next microarchitecture using 10 nanometer processor. However, Intel later revised their roadmap to include Kaby Lake. The Kaby Lake microarchitecture uses a modified and improved 14 nanometer used for the Broadwell microarchitecture. Intel calls modified process 14 nanometer plus. The new process has improved transistor channel strain. The various enhancements improve performance without increasing the capacitance. These changes allow Intel to increase the maximum frequencies of all models by around 100 to 300 MHz, which give many single thread applications a modest performance increase. Overall transistors improvement allowed for plus 12% drive current. While there is no change in pure IPC over Skylake and the actual microarchitecture is largely the same, Intel introduced a number of enhancements in Kaby Lake. Note, because of the improvements done to the process and the uplift in binning, it is the most ultra low power processor that will see the most substantial gain. Likewise, the high end models will see very little gain. The enhanced manufacturing process allowed Kaby Lake chips to be highly overclockable, with models such as Core i7 7700K capable of comfortably reaching 5 GHz for many people with a reasonable cooling setup.
Architecture memory directory basically consists of number of caches like L1, L2, L3, L0. L0 microoperation caches consists of 1536 microoperation sets having an 8-way set associative and 6 microoperation lines and 32 sets. Then we have L1 cache. L1 cache is also 8-way set associative having a 64 sets, 32 KB and 64 byte lines and shared the two threads. L2 cache is 4-way set associative having a 1024 sets and 64 byte lines. Clock domains. Kaby Lake is divided into a number of clock domains. Clock domains are basically frequencies that have respective unit in the processor. All clock domains are some multiple of the base clock. Base clock is an interface frequency of 100 megahertz and it is a reference for all other clock domains like core clock, ring clock, IGP clock. The frequency at which the core and the L1 and L2 cache operates is a core clock. The frequency at which the ring interconnected and LCC operates is a ring clock, and the frequency at which the integrated graphic operates is a IGP clock. Then we have memory clock. Memory clock is just like others as well, at which the system memory operates. Every clock is assigned to a specific operation. Then we have pipeline. Pipeline is divided